Thank you. Good afternoon, everybody. I think we're about ready to get going. Thank you for coming in this afternoon. I know it's a busy show and you're all taking an opportunity to take a seat, which I don't blame you. Today we're going to have a quick look at the hard truths about soft token authentication and more generally around OAuth, and see if we can enlighten ourselves around that. So where do we begin? Well, here's a good start. So 65 million years ago, we had a couple of friends running around the Earth, and not long after that, someone came up with a PIN code and a password. So there's been a bit of evolution since then, which you've probably seen a few examples in the halls outside of various wonderful creations that's come along, about how people can log into stuff and prove who they are, and there's some really interesting psychedelic ways of doing it. Now, the way we've got there is the password. We all know that. The free thing that actually costs everyone a lot of money in the end because they all have a price. Things have moved on to phone calls. You've had a few of those when the bank's server calls you and speaks to you in some robotic voice. And you've got your keyring generators, SMS text messages. We all get those. Calculator tokens. Anyone got one of these? Great fun using these. And card readers, just when you thought the token couldn't get any clunkier, someone gives you one of those. So this is the kind of stuff that's been evolving and what we get to use. So the bottom line, guys and ladies, the dinosaurs are not dead. Unfortunately, this stuff that we're seeing a lot of outside still, what you might be using today inside your organization, hasn't really evolved a lot since the first sort of OTP tokens came around. And they've proved to have issues, let's say, which we'll look into some of those in a minute. But after all that plethora of stuff came around and all these bespoke systems happened, finally someone thought, let's get some standardization. Let's try and make this stuff work together, simplify it for deployment, usability, all the rest of it. So hence we came up with OAuth. Well, I say we, I wasn't involved in it, but the standards came around. So if this is the two RFCs, the main ones. Go take a look. They're as old as 2005. Again, this stuff is not new. So you've bought your shiny new OAuth-based solution. Yep, it's that old already. All right. Quick question. Anybody read any of these RFCs? Show of hands? Okay, you've got 2 or 3. Okay, well, for the rest of you, there's a test on this at the end. This is the RFC. Oh, don't worry, there's more. There we go. Okay, that's now you've all seen the whole of the RFC. Okay, so now, literally, there is a pop quiz on this. Can anyone tell me how many factors of authentication OAuth is designed to work for? Okay, any other guesses? Come on. You all had lunch. Okay, everyone assumes that OAuth is two-factor authentication, right? No, it's one. Scary thought. Okay, so the second factor is something that is 65 million years old. It is a PIN or a password. Because if you think about it, every time you use, one of these things, which I'm sure some of you have one, you don't have it with you, which is a whole other problem with these clunky things, is that, well, if I press a button, I get a number. That's one factor. That's not two-factor. The second factor is the PIN code or the password you use, which probably haven't changed in 5 years. That's the reality of how these things are working today. So what is OAuth if it's not two-factor authentication? Well, that's all it is, actually. It's just a really cool algorithm that generates random numbers. Okay, so it's demystifying what is this stuff. Because there's a lot of vendors out there that build a lot of things, and you see OAuth and all these standards-based stuff plastered around it. But it is not actually anything that revolutionary. It works. It's very good at what it does, but it is not the be-all and end-all. So if you look at these RFCs, now you've all obviously read it anyway. So this is one of the key listed ambitions of OAuth. What was it designed to do? What were the problems in 2005 that the guys that wrote this stuff were looking to address? So there was a highlight at the time of a lack of interoperability amongst different vendors. Everyone had their own proprietary thing and the way it worked. Part of it ended up being built by design for vendor lock-in. So you spend all your money on this fancy vendor solution, guess what? Who are you going to be buying your next set of tokens from? Well, the same vendor. There was no coincidence there. It was designed that way. So OAuth was a way of standardizing this stuff so that everybody could play nicely together. Well, okay, costs as well. Now, all these proprietary different methods of doing things had costs associated with implementing and managing and then maintaining. And yeah, when you think about limited innovation, there was a lot of that, but over the time with these clunky card readers were still being issued. Has that really changed? So if these are the ambitions in 2005, how much of this is still valid today? I don't know, I'll probably argue a lot of it. You can find a lot of vendors out there that talk about OAuth, yet they won't work with each other's stuff. It kind of goes against the point of it. Some will, it's not for everybody, but generally you'll find it won't work that way. So, some of the real-world challenges. Now, just to set the scene, some of these real-world challenges aren't specifically OAuth, it's just more about the stuff that's available out there right now. So, yep, we've got things like phone calls and text messaging, or out-of-band, as you might call them. There's a lot of marketing terms around some of this stuff, and your challenge as a participant here is to figure out what they actually mean. But, you know, some of the challenges you've got in real world is signal issues, delivery delays of text messages or SMSs, language and accents and dialects, all these things, the voice-based stuff. It's always challenging. So I don't know what language that computer speaks when it phones me, but sometimes it's a little bit challenging to figure out. Keyring generators. Who's got one of these key fob token things? Then hands up. Okay, those with the hands up. Keep your hands up if you've got it with you now. And all the hands go down. Okay, there we go. There's another one of the problems. No one keeps things with them. They're in a desk drawer, they're in the car, they're somewhere in the kitchen table. So right now, do you have it to prove who you are? Well, no. So there goes that idea. Okay, part 2. Soft tokens. There's a lot of evolution in this lately, thanks to the good old App Store. Big challenge of soft tokens a while ago was that you couldn't get an app onto that weird, clunky, so-called smart device 5 years ago. Nowadays, everyone can install Angry Birds, so you know what? You can get it on the device. However, there are still some challenges. All right? Mobile phone platform coverage. There are loads of smart devices out there from different vendors. And depending on if you've got a BYOD policy in place or whatever the system being, you're not going to have just iPhones or something. There's always a mixture. You've got to cater for that. Okay, some need data connectivity. How do you do that with your international roaming? That can get expensive. £3-4 every time you want to log in might be a good idea. All right. Some of the UIs and interfaces are built for techies, not for end users. Download a few off the App Store and see what you think. Okay. Cloning them, interesting one. You've seen some of them, you can go and like take a picture with the soft token app of QR code and it puts a seed in. Well, so can anybody else with a phone and a camera, and now you've got a clone of that soft token. Some of them work a bit more intelligently, some don't. Things to look into. And don't forget, at the end of the day, all this stuff, the second factor is still that PIN password 65 million year old issue, which we're trying to solve by putting in two-factor in the first place. All right, some extreme workarounds. You can Google these things, actually. It's something interesting. So we have how to turn an RSA keyring into a web-based solution. That's one way around. And in a bit more ingenious way that someone did with an HSBC token, they wanted to be able to log into their internet banking over the internet without having the damn thing with them. So they built something with, you read the write-up, you send a text message to a phone which then presses this button and takes a picture of the thing and emails the photo to the user. Okay, if that works for them, not say everyone's going to do this, but you get the point. Doesn't mean because they issue these tokens, they're used in a way that they expect them to be used. And there's a whole lot of more out there you can go take a look at, but hopefully it makes the point. Okay, so we're going to continue this authentication evolution. Where are we going to go? So if you think about a version 2, something's got to be convenient and easy to use. Because seriously, why do you not all carry those lovely card readers with you? You've got room in your pockets. Sure. Okay, accessible from anywhere. You've got to be able to prove who you are, wherever you are, and whatever you've got. Otherwise, you're really limiting the scope of use. Cost effective. Sorry, you can't keep buying 50, 100-pound keyrings every 2 or 3 years. It's just not really going to cut it. Risk appropriate. If you want to do something simple that's low risk, this should be more on the side of convenience, not 3 levels of security and a strand of DNA to get into it. You need to be able to think about how to do things appropriate to the risk. multiple usage scenarios. Am I logging into a web-based app? Am I connecting to a VPN? Am I accessing the door of the building, etc.? Common attacks. Some of these things, they put little bits of code in to try and thwart a known attack. What about the next one? So think about things by design and strategy to mitigate things. So we've got man in the middle, we've got man in the browser, and next week there's man on the moon. I don't know what comes next. The point is, you can't code against a particular threat. There's always going to be another one. So you've got to think architecturally how to work around things. Okay, web apps, mobile apps, in-app authentication. Anyone looking at mobile app solutions, there's a whole new world of how do you authenticate these things. It's things to think about. So if you're looking at solutions, think about vendors with SDKs, how to integrate it into existing systems. But you still have to deal with legacy systems as well. All right. So the key is that OAuth alone is not a solution. Do not go and buy OAuth. A, because it's free. It's an RFC. You can go and download free source code and you've got a solution right now today. Okay, it's just a building block that you've got to build other stuff around. You've still got to put it in, manage it, integrate it, and work with it. All right, some examples of where this has failed us. The legacy version 1 of authentication. About, according to this research anyway, 52% of companies reported higher severity and frequency of security breaches over the last 2 years. This was from a report in February this year. So this is since OAuth has been around since 2005. So it's getting worse. You've probably seen Operation High Roller. Anyone seen that in the press? Okay. A lot of money stolen from bank accounts from all over the world. Very clever attack. I haven't got time to go through it now, but effectively it used the 2FA token the user has in their possession as part of the attack, not as a mitigating factor against it. Same thing, Eurograbber, similar type of thing, made use of OTP tokens sent to a phone with SMS or text messaging to get access to people's bank accounts. So in sort of a utopia slide, what would good look like? Something you have should be low cost, start off with, easy to use, flexible. At the end of the day, it's not IT people that are using these things. It's users. They're there to do a job, not an IT job. They've got to get on and do something. The key thing, I think, is that something you know should be something that stays in your head. Why aren't passwords and PIN codes secure? Because every time you use them, you give it away. As soon as you type it in, someone else could have a copy of it instantly and reuse it as many times as they want. So it's no longer something secret in your head. So that factor is very easy to get rid of as being a second factor. Keyloggers, etc., are extremely commonplace. So we need a way of abstracting that into a way you can keep that knowledge in your head without giving it away. Things like linking an event or an action to a user, adding a payee to your bank account. You want to know you're adding the correct bank account number and something in the browser hasn't changed it to your neighbors or your bad guys, your ex-wife or whatever it may be. Okay? Make sure you know what the person's doing, not just who they are, and then they end up doing something they wasn't intended doing. Okay, back to the use anywhere, any device. We've all got tablets, phones, laptops, televisions with browsers and webcams in. Okay, this is the way of the modern life. How does your token or your ability to prove who you are fit in that world? And it needs to be evolved with threats. Say the man on the moon or whatever the next attack is. Okay, how do we deal with the next one? There's always going to be a next one. There is no silver bullet for stuff. But if you've got something, for example, soft token base is built in software, you have an ability to easily update it. If it's a piece of junky plastic, which is designed never to be tampered with, and it becomes a faulty product, how do you update or change it? Well, we've seen that from a certain big vendor recently, how they dealt with that one. Okay, so close solutions so far, I've mentioned software-based tokens seem to be heading that direction based on the market trends and what people are seeing and saying, because you can update them, you can easily get them out there, the costs are a lot lower. Okay, but they're not all built equally. Okay, some are built in all different parts of the world, some are outsourced, some are etc., etc. You get the idea. Some are built very well, very user-friendly. Others, well, not so much. Just an exercise to do over coffee one day. Get out your iPad or your phone and just have a look on your app store of free soft token applications and just install a bunch. And you get the idea of the gulfing difference between usability, because think about a user has to use them. Okay, things to keep a look out for. You do not want a soft token that requires data connectivity post-installation, because suddenly you limit the usage. If you haven't got 3G data coverage or Wi-Fi or international roaming, you can't use that thing. So, yeah. All right, ideally something should be tied to the piece of hardware. The software seeding process, A, it's a process nightmare. B, it's very easy to clone devices. So your assurance level of that token goes down dramatically. But if the token by design is built to use the hardware of the phone in the first place, as an example, say tied to an IMEI number, then you've got a good level of assurance of uniqueness of that device. Okay, data entry capable. In other words, something with a keyboard or a pin pad or something on it. So you can do important things like transaction signing or transaction verification. If it doesn't have that input capability, you've limited its usage from day one. Okay, it's got to be ubiquitous as well. So it's in every device, on every app store, sort of wherever you might want to use something. And if you can cover those things off with a software solution, you've kind of got sort of Authentication 2.0 covered at the moment. Obviously, there will be version 3 later on, and come back next year for that presentation. But you see where we're going with this. We carry on with trying to recreate Authentication 1.0 with slimmer card readers, with rounded corners, and it's now red or brew or whatever. It doesn't really change the core problem they all create. Generating an OTP code and requiring a 4-digit static PIN, which no one changes, is kind of done. It's not new, and it's proven to be faulty time and time again. Okay, the other thing I forgot to mention was the knowledge abstraction layer, which is about having a method in place to keep the second factor, the knowledge factor, secure, so you don't give out the crown jewels every time you log in. So if anyone's curious how we do it as an organization at Infosec, coming down to see us at Stand P90, just as a quick plug, we have a single service solution with 3 authentication technologies in one box, and you can use it on a whole bunch of different devices, from phones, tablets, web-based access, all different scenarios with a single method of doing things. And funnily enough, through some coincidence, it also kind of fits that sort of ideal, what would the future look like. Don't know how that happened. Oh well. And oh yes, we're on 6 app stores at the moment, so whatever mobile device you have, if it has an app store, our app is on it already. So it's not a future thing waiting to come. So go and have a look for us there. Okay, well that's all from me at this point. If there's any questions, we're happy to take them. Otherwise, please fill out your evaluations before you disappear. Unless you have a question.
In the beginning, you mentioned about 1.5 factor authentication. What is that?
Right, okay. I'll just repeat the question quickly. The gentleman asked a question about what is 1.5 factor authentication. From our point of view, it's a marketing term. It's actually one-factor authentication with a twist. The twist being the extra half doesn't give away the secret information when you use it. So if you think about a password or a PIN code is one factor, it's knowledge-based, but every time you use it, you're giving it away, a keylogger or whatever is susceptible to capturing it. So in our solution, we've termed what we call 1.5, and the 0.5 is A, so people ask the question, so that works well. But it also, the technology behind it keeps it secure. So we're able to deliver an OTP solution without having a second factor. So if you imagine you turn up to a web page, like this one, if you're internet banking, you type in a username, you get given a challenge within the web page, and you type in an OTP code without having a second factor. Now, that's pretty powerful if you think about the usage scenarios of where that can be delivered in any organization, internal, external, wherever. So you're getting a lot of the benefits of why you deploy two-factor, sort of that you can't keylog it, you can't replay it, you can't screen scrape it, all those things. You can get a lot of those benefits in what we call a 1.5 factor solution. Is it as secure as two-factor? Well, no. Let's be straight about that. It's not. It is an in-between because many benefits of two-factor, but it's still a single-factor solution at the end of the day. However, it is a lot more secure than just using a PIN or a password. Okay, does that answer your question? Okay, thanks. Any other questions? There's got to be at least one more. No one else brave enough? Ah, there we go, so thank you. Can you? Thank you.
Well, when you were saying you tie your OAuth to your device, but people have multiple devices, so how would you manage that?
Sorry, did you miss the first part?
If people have multiple devices, how do you manage tying it to a single device?
Right, okay. How do we handle multiple devices to a single user? Well, it's again keeping up with the current world. Everyone's got more than one smart device. In our solution, we allow you to have up to 10 mobile devices, whether it could be iPhone, laptop, tablet, whatever, all linked to one user account. And we only charge per user, not per device. The tokens are free to download. So we built that into our solution from day one, recognizing that that's obviously a real world scenario. You don't have just one device with you anymore. Apple's made sure of that. But yeah, we're able to cater for that. So you literally go on the user account and say, I've got a BlackBerry, I've got an iPad, I've got an Android, and you just fill in the device IDs of what each platform is, and they all can work. And you can turn them on and off depending on which one you want to use. Okay. All right. We've got time for one quick question at the back there, I think. Oops. It's at the front here.
OpenID along with OAuth?
Sorry, it was about
Do you support OpenID with OAuth?
It can be supported with OpenID. If you want to plug in identification, identity management solutions, they're all there to be used. But yeah, it's look at the architecture. There's a whole different story around that. But yeah. Okay. All right. Well, in that case, we'll call it time on that one. Thank you very much, everybody. If you have any other questions, you want to come to one-to-one, or otherwise come on down to our stand, I'm more than happy to cover anything off, or one of my colleagues can answer a question as well. Thank you.